Welcome to another tutorial about the structuring of architecture in Blender, which is a very important issue. And this is extended as well, and it's another exercise. This exercise is very principal, and I like it very much, because now we are following the path of crystallography. And what we will create is this kind of structure, and this is built from a single element and can have an infinite structure in space. And you see it's very precise, and the jointing of things here got very complicated in its symmetries and so on. And this is what I think is at stake in 20th, 21st century architecture if we want to get a master. The reference of our tutorial will be Fritz Bauen und Forschen, and you see this crystal here. And we go in depth. It's he calls it the problems of jointing elements. And following Conrad Wachsman's universal node, following crystallography, and he sees that in a simple way in these desalinations, and in a more complex way in three-dimensional space. He gives a reference to molecules and chemistry, and we have DNA today and so on. And I think computing is about the same thing. So all this has a reference in group theory and category theory in mathematics, and crystallography as a theory of group theory in space, of growing things in space. Different views to all the same structure with certain symmetries, different models. All this is done in the end of the 60s, beginning of the 70s. This is our candidate. We want to model. You see the configuration here. It's homogeneous spreads in space in a homogeneous way. And this is the element. You see the symmetries here, plus, plus, minus, minus. This is a principal cube with 6 of these elements in a certain configuration. And you see here how the symmetries in the junction is set up. So we have here pictures about the symmetries, another setup. Okay, this is our reference. So we want to, first is we go to our prototypes. So we first create prototypes, and then we have layouts. So prototype, they are here. So now we create an object, start with the cube, and we want to have the thin plane. So let's look at it. So this is our cube. Never scale, rotate, never scale or skew or mirror an object. Always go in to the design. This is the the production of these things, and this can change the shape. So therefore, now scale in Z direction by so very, very thin. So now let's look what we have. So this go out. So this is our principal element. Pole plane. So, and in the first step we want to have a schematic, diagrammatic representation of our crystal, which means we need, I suggest to get some surfaces. So we create node editor, go here and create a surface, and then get a texture, and I prepared the texture, open that, no, that's the wrong one. I prepared this one. Here we are. Now go for the UV image. So this is a schematic JPEG, and it represents magnets. So it's plus, plus, minus, minus, and to fit things you always need a plus with a minus and a minus with a plus. And the front is plus and the back side is minus. By that we can join these elements in proper directions and can have a clear overview of how the symmetries work. So now we have to apply this to the surface. So this is the scheme, magnet scheme. So now we have to go in and select the top surface. Why? So, okay, top surface. If you have that off, you select all the surfaces. We don't want that. This is just the facing one. So now we have that, and now we got the top surface. You see that, and selected that. Now we say U and set to UV mapping, which means get this polygon here, this face mapped to the image. So UV mapping, unwrap to the image. And now it fits fully to this, this image. If we now go for texture, then we see we have this texture on the front, and on the back we don't have it because we just selected this surface. Now if we go to the back side, do the same thing. Select the back side and do the same thing. So U, unwrap, and here we are again. And the problem is, you see that we have to turn that. So you see, if this is a magnet, then there should be red, that's fine, but here there should be red as well. So therefore we have to turn it 90 degrees, and we can do it here by rotation. You see what happens. So let's look how this works. And here now we have fore and back front perfectly done. So this is our principal element in a diagrammatic, sketchy form. So go for object mode and leave this window. So this is our principal plane. We are in prototype, and we are on LOD, level of detail 1 or level 1. So now we have to give that a group, and we say we create a new group, and this group is module D. This is a name Fritz used for it, and we are Currently we want to work on this level 1, not to get confused. So we want to have all the module D objects on layer 1. Copy it in these duplications. So go here for just a visible layer. So that's our prototype in the library. Save the whole story and say, for me it's A4 generic cube V. Good. Now we go for the layouts. Take a copy setting and say this is layout 1. So insert, now we have our module D, we have this. Then we say duplicate and rotate it, for example, around X, rotate X 90 degrees, move it this way, and this fits. Now minus and plus fit well, and of course the backside fits as well. So now duplicate, and now we have a duplicate of here. If we want to turn it here, we have to rotate around Z. Rotate Z 90 degrees, move it, and here we are. This is fine, this is not. And the same on the side here, it's not. So we have to turn it around here. So this is the x-axis, so rotate x. And this should be, is it 90? 90, you can see it down there. Here we are. This is perfect now. Good. So what we can do is, because this now is the element of replication, so or just continue to make a cube whether this works, so you see the schematics of that. So duplicate, and this is y-axis, so this always works. The same here, duplicate a z-axis. This works, great. And then we take this guy, duplicate an x-axis, here we are. So it works perfectly well. So, and now simply by the rotation is proper, and now simply by translation, you can take the bottom one. So all this will work. So duplicate y, and this simply works. So this is what the crystals are doing. They're growing like that. Duplicate a z. Look, it works. And the whole story is proper. So we can take him, duplicate Z here, move it here, and all this stuff works. Okay, so that's what we have. Make it so this is a good setup for layout 1. You can have all these alternatives. So this is our layout. Next step is we want to go into the geometry of this element. So we have to design this element. So this is a kind of interface to understand the symmetries of this crystal. And now we want to go to the design of the actual part. On level of detail 2, we think about 2 sheets of metal or wood, for example, and they need to be built in the same symmetry like this. So let's make a sheet in the same size. So here, don't scale it, always in object mode, always go to edit mode, otherwise you will get a mess. So now this is 2 by 2 by 2 meters, and we want to have it, scale it down to 2 centimeters. So therefore it's scale Z by 100. So that's it. And we want to move it down by 1 centimeter. Z, not 1 meter, but minus 1 centimeter. So that's it. And then we have to look at the symmetries. This was blue and blue, red and red. Therefore we want to have it asymmetric. So we cut the depth, so it's 2 centimeters off here and leave it here. So get this and cut it by 2 centimeters, minus 2 centimeters. And do the same here. And this is minus 2 centimeters. Okay, now we got it asymmetric. Go back. So now we want to doubly link that and rotate it, make the symmetrical part. So it's Shift D to doubly link, have that, rotate by Z by 180, and here you see we have the symmetry, this asymmetry we wanted to have, and now we have to mirror that, mirror around, confirm around the Z axis. So this is our asymmetry we want to have. It's plus red, red, blue, blue, and on the other hand it's exactly the opposite. So it's the same symmetry, and by that it's working by principle. That's the beauty of these things. So if we have that, we simply say this is our element. O1. This is element O1 doubly link. So, and they are with this group module, and they are with this group, with this group. And now we switch from LOD1 to LOD2, and by that, now go back. Now it's only 1. Now here we are, and here you see the things fit properly. So nice ways how they are organized, and you see the complexity, and it's proper just because we followed these symmetries. Good. Okay, now next level of detail to go to the actual construction. Not have these principal spatial things. Now we need tolerances, and we want to bevel the edges. So therefore, then these edges are better readable, in a better way. So therefore, we don't have to touch the architecture and these crystals. We just have to work on versions of how to build it. So this is LOD 2. Now we want to have LOD 3. Duplicate, not doubly link. Confirm and move them to layer 3. Okay, if we go to layer 3, we have it. Now we choose the upper element, therefore they are linked, so we only have to modify one, and we keep the symmetry by our dupli link and the mirroring. Now we can go in here and edit the thing. So we want to have 1 millimeter tolerance and gap, so which means it's half a millimeter smaller. This has to be smaller by half a millimeter on each edge. So we have to model it by hand, so that's always very disturbing. So, and we can't see that, therefore it's by numbers. So it's minus 0.5 millimeters. Okay, deselect. Have to be very schematic. There's no way to control it. 0.5 millimeters. Now it's positive in Y, 0.5 millimeters. And here it's positive in X, 0.5 millimeters. Now these are now the tolerances, and we had this upper part. Now we want to do bevel the edges. So select them. This one, this guy, this guy. Okay, now we have them. And then we go here, meshes, edges, bevel, confirm. And here we see the parameters. So, this is too strong. So that's fine. That's smooth enough. That's good. Okay, deselect everything, go back. Now we have a nice element, and we have the mirrored element as well. And that's it. Give it a material. It's white plastic. Principled BSDS, so take the default. Okay, now, and we have, this is inherited by copying with module, but we don't want to see layer 2, now we want to have layer 3 of our module D. So if we go to layout, we have a much better view to our edge. Good. And now you see how they are organized. Good. If you want to render that, we choose another layer for the sun. You go here and the plane. So go for stage. Scale by 6, and we have 1 centimeter down, so put this here first to 0, that's fine, and then minus 2 centimeters, so then we have the lower edge. So that's the plane. It's on the last layer, and now we have the ground. The ground is orange. Good, look for material, so that's our ground. Okay, Now a camera. Put it here. Good, that's fine. And sun, 0.5, 3, and here 80. Good. So all this now is on the visible layer, but we want to, the module, they are here, the sun is here. Okay, so now if we switch it off, these are all elements. Good, that's fine. Now we have both. That's good. What is with the world? Go for the world. Say this is a day. Surface, give that like yellowish color, very light, and go for the rendering. So if this is our view, then the shadow should be on the other side. Yeah, something like this. This is a good setup. Adjust the camera again. Good. And do the rendering if you like. So, rendering is here, will be fine. So this will take time, so we don't do it. But look at the details. They're proper. If you want to make a new layout with the same elements of your database, switch here, go here. For example, take these elements here. You only need the 3 directions, and duplicate them and move them to the second layer with an alternative layout in layout 1. We have a different layer, and now, for example, just to make a single cube, or no, go duplicate this guy, duplicate it again. So this, duplicate Z. Duplicate. So make this kind of box if you like it. So, and now we have the same setup, and you see it's very fast in doing these things, even with the camera. Okay, and of course we have all the details. Yeah, very nicely done. That's it. And of course we can go for the prototypes and say we want to not have level of detail 3, go back to level of detail 1, and go to our layout, and here we are with our schematic layout, and we can count and look for the structures in a very in a very obvious way. So this is the interface to our structure and our architectural design. So this is what I wanted to show you. Hope you find it interesting, and see you in the next tutorial.